We're asked to write 2x squared plus 4x minus 5 in this form. Note the 2 has been factorized out from everything. Normally, this is completing the square, by the way. Normally, you just factorize the 2 out from the first two terms, but it wants to do it from all of it. So, okay, we'll do it. So 2x squared plus 2x minus 5 over 2. That's what I'm going to get. Now I'm going to complete the square on x squared plus 2x. So the quick way to do it, I'm going to go into a little bit more detail, is that we have that 2 to get a plus 1 with a square in. And this will mean I get x squared plus 2x, because you get a 1 times x and another 1 times x. But then I'm also going to get a plus 1, so I need to minus 1. And of course, I'm also minusing the 5 over 2. This then, if I keep the bracket, will become x plus 1 squared. Then this is minus 2 over 2, so I'm going to get minus 7 over 2 there. And that is going to be our final answer. I don't need to say, I mean, P is going to be 1 and Q is going to be 7 over 2, but it's not asked us to specify it, so I'm just going to put a box around that. Now, just before I move on, a little bit of information on why this works. So imagine I have a rectangle and it's x plus 2 in length and x in height. This area would be x squared plus 2x, which is what I've got here. Well, we can split it, so we've got a square. So this length on the left is going to be x, and then I've got 2 here. But then I want to turn this into a square, complete the square as best I can. So this is why we split it up into 2, like this. And then imagine moving this bit, like get rid of it, and move it round so it fits perfectly here. So I now have nearly a perfect square. I've just got this bit missing, this purple bit. So we can see that we've got x plus 1 squared, except I have to minus 1 as a consequence, and that's geometrically why the method works. And you can do it. I mean, when you start getting negatives, it's more awkward, but practice these. I mean, if you want to really get your head around why it works, and it might help you remember it. At the end of the day, you just have the coefficient of x and put it in a bracket, and then minus the square of that number. It will always work, but this is why. Okay, we're then asked to hence state the minimum value and the value of x at which it occurs. So the first thing I'm going to do is actually multiply the bracket out. 2x plus 1 squared minus 7. Now this is always greater or equal to 0 because I'm squaring a number. It can never be negative. And that means as a whole, the whole thing must be greater or equal to minus 7 because I've got something that's bigger or equal to 0 and I'm minusing 7 from it. It couldn't possibly go lower than minus 7. And that's actually going to be the minimum. And it's going to occur when this term disappears. So what makes it disappear when x is minus 1? So that is my minimum value. Let's move on to part B, so unrelated. We've got in a controlled experiment, the number of bacteria follow this exponential function. Find the initial value of n. So it's actually just going to be 500. Slightly longer way to do it, initial means when t is 0, and then it would be 500 times e to the 0, but that is just 1. But whenever you have an exponential in this kind of form, it's always the number that's right here. Then we're asked to find the time in whole minutes for n to increase by 48%. So it starts at 500, so I would be timesing that by 1.48. That's my multiplier to increase by 48%. And that is going to equal 500 e to the 2t. I can just cancel the 500s out. Actually, we're interested in when this exponential part is equal to 1.48. For this, we can use logarithms to undo the exponential. You could take, I mean, there's a couple ways to think about it. You can go straight to writing 2t equals ln 1.48, but you can imagine taking ln of both sides. You might prefer to do that. So then we can bring the power down and we just get ln e, which is 1. So ln of 1.48 divided by 2 to get t is going to be 0.19602. Now, the original time was actually in hours, and we're asked for it in minutes. So just got to convert it. 1 hour is 60 minutes. To go from hours to minutes, we times by 60, and that's what I'm going to do here. So 11.761. They've asked for the time in whole minutes, however, so actually, whilst it's going to be during the like 12th minute, it's actually going to take exactly, well, it's going to be 12 minutes for it to get to it. After 11 minutes, it wouldn't have quite got there. So overall, 12 minutes.